Welcome back, everyone, to Merge Conflict, your weekly developer podcast, talking about all things in the world of development and probably AI as well. I'm one of your hosts, James Bonson-Magno, and with me, as only, the one, the only, the beautiful Frank Kruger. How's it going, buddy?
Ooh. Hi. Yeah, I think I'm the only other host. Sometimes you replace me though. So I guess we do have 3 or 4 or 5 hosts, but I'm usually the one here. I'm usually the one talking to AI. It's not true. I think you get paid to talk about AI now. Someday I hope to get paid to talk about AI. Hi, James. That was a long intro. Good to see you, buddy.
Good to see you as well. Yes, I think Burke, talking about holiday hacks from last episode. Burke put out a blog post about his holiday hacks and how he was making all this stuff and how Opus 4.5 like changed his life and all this stuff. And then it got featured on Hacker News. And then I
Oh,
decided to analyze all the comments and things, as there was like hundreds of
right.
comments. And people are mean on the internet. Um,
Oh, why? What did they say? What was the
I don't
meanest thing?
I'm not gonna find the meanest thing, but
Okay,
there
I'm
was
just kidding.
I ran it through feedback flow, and the sentiment was about 60% positive, which is actually pretty good.
Okay, yeah.
And AI skeptics or AI haters and AI folks out there, they're going to show their counterpoint and back and forth. I think
Yeah.
one thing that people talked a lot about was Greenfield versus Brownfield. That was a big topic. And then
Mm.
additionally, to your kind of point, was they're like, oh, well, look at this guy's Twitter account. Isn't this guy just like paid to talk about AI? It's like,
Oh.
yeah, like Burke works on the VS Code team in advocacy at Microsoft. Like, yeah, I mean,
It's not hiding it.
I
But,
mean,
yeah, it's tough. That's always the pros and cons of Hacker News. The pro, obviously, is you get a bunch of exposure. The con is there's a bad on Hacker News, everyone is trying to show how smart they are. This is an over summary of it, but there's a lot of machismo and people trying to sound smart, look smart, prove that they're smart, and they often do that by being contrarian. I'm sorry, I'm jaded. Hi, I'm Frank. I'm jaded. I love being featured on Hacker News, but you get tired of it after a while because there is a very competitive thing where no one can just say, "Hey, that's great." They have to say, "Hey, that's great, and here's where I would have done it better." It's always
yeah,
that little extra.
yeah, it's a yes, but instead of yes, and yeah, and I do think that so one thing to kind of note, which we talked about on the podcast many times, is the topics that we talk about are things that are passionate and interesting in our lives, and those things have ebbed and flowed over the years. They're usually
Mhm.
revolve around mobile development, usually around C sharp, but not always. We talk a lot about different things, and we experiment with a lot of different things, more experimentation than ever. But inherently, when you think about developer relations and developer advocacy and community things that people do at any company, the reason we do it is because we actually enjoy that technology,
Yeah.
right? And like we enjoy it and we use it. Like Burke wouldn't be talking about it if he actually didn't use it and enjoy it. But there's obviously some
Yeah.
bias because we work at like take the bias at heart. Like we've always said, I work at Microsoft. There's inherent bias there. Just like if I worked at Google or you worked at Meta or you worked at Anthropic, you know what I mean? There's inherent bias towards, well, yeah, my thing's the best thing that I'm going to use all the time. I'm not
Mhm.
be it might not be the best, but at least for my scenario, it's the best. And I love it, right? I'm a company man. So I think, take the bias, but of course everyone's gonna have bias because there's bias in
Yeah.
everything, right? So,
There's no
but
such thing. Yeah.
inherently, every single person I work with actually really, really likes the product. And they also know that's not perfect. So we drive feedback as well. So I think that's kind of a,
Mhm.
a thing to remember in general. But I think it actually gets me thinking about this, Frank, which was when it comes to AI coding assistants, we often do talk about um, a lot of greenfield applications. I talked a lot about brownfield applications recently, by the way, I mean, migrating and adding new features to existing applications that I built many years ago, which can completely be done, by the way. Um, I think the coolest part is when does something greenfield turn into brownfield? So, for example, Mads Christensen, who's world renowned for Visual Studio extensions, works on my team, and he made this awesome extension for Visual Studio, which was called the GitHub node. And as we know, the .github folder is very important in the world of AI. And in VS Code, it shows you a folder view, it's all there. Visual Studio does not, which
Ah,
means that you can't see those files. So he literally made a node that just shows up in your solution, shows you the files. And I
smart.
said, that's pretty cool and I love it. and he vibe coded it out. And extensions are not easy to make, by the way, because there's not a lot of them. Like there's like the corpus of data is not a lot. I guess Mads has his own to like, but he should probably create his own model. But I was like, it'd be really cool is if there was a node that showed you the MCP servers, because it's actually really hard to
Mm,
find your user system, your syssetting, this thing, and see what's inside of it. I want to click, go, add it. It's actually quite difficult in Visual Studio. You can do it, but it's not in your face. So I vibe coded out this afternoon in 30 minutes. Like, was his thing that is now shipping Brownfield, and then I added to his Brownfield app, or is it all Greenfield? I don't know. Like when when does it change? But I think that gets me to the bigger point really quick, which is using AI to work on things that like inherently don't make any sense really to use it on it, but also gives us a superpower to work on crazy things that don't make any sense. And I'll talk about it like this. Like, what if, for example, you could use it to like write like Arduino code, like and
yeah.
write little circuitry and things for the SB, right? And then, or you could take it and you could reverse engineer things, and you could like write a bunch of like really crazy old C code. Or I'm saying like things that aren't modern. We're talking about web applications, talk about this, but I think about that little heart that you made. So Frank, for our wedding, made this little heart, which has an LCD display in it. It's like Arduino ESP32 in it, or SP32 in it, and it shows like the countdown to I think our wedding, and then our wedding until then it
Count
counts
up.
up,
Oh, yeah,
counts
yeah,
up. But it
yeah.
needs Wi-Fi, and I have no idea how to program it or how to do anything. However, now like I could take that source code and I could actually modify it,
Mhm.
add features, and do a lot of stuff to it. And that's something that I would never think about doing before. That's not even that crazy. I'm thinking like COBOL code, like older things, crazy
Yeah.
embedded code, all these things, Fortran code, right? Like this thing that we don't think about as modern flashy web in your face, but actually you could do this. I think Fritz over the holidays was doing like this, it kind of reminded me of that. Remember that LED board that would like connect to like my web server and show a number on it. But vibe coding that out, like little IoT devices that have this embedded code, I think is this other scenario that I'm starting to see kind of light up in general. It doesn't have to be this flashy, mobile app or website or something like that. And I know that you've been up to some craziness as well. But it had me thinking because over the holidays, yeah, I did a bunch of websites. That's easy. But like also like crazy little embedded, whatever. Like I think of this, like, I'm gonna shut up. Like
Mhm.
there's this, I got my Nintendo Switch. I have this little Nintendo Switch pinball cabinet that was 3D printed. The guy from Japan makes it. It has a little board inside of it, has a little controller to do this. But what if I wanted this to work on Nintendo Switch too? Like I could like now write code that would go on that little board that would do stuff that I could, I could program it, and it would like be able to like, speak these programming languages that I never would imagine that even aren't necessarily modern or updated or anything like that. So that's kind of my head's at
Mhm.
for today's topic.
Yeah, it's a great topic, and it's a good timing, James, because I have exactly the right project I want to talk to you about with all, regard to all that. But first, I actually I want to address your Greenfield, Brownfield. Are we really calling it Brownfield? Is that a thing? Um, okay, it's just what it's called. Old code, new code. Let's go with that. I've actually been thinking about it a lot today because I have been adopting the James style of programming, which is sit on your butt all day and just tell GitHub Copilot to do all your work for you. I call it the James way. And I enjoy it. But I found the control freak in me freaks out a little bit because it's hard to give it architectural suggestions, or it might get some broad architecture things differently than how, say, I prefer it, or some UI things. And what I think you're supposed to do is fill out a bunch of agent MDs and instruction MDs and give it a lot of prompts and that kind of stuff. But I'm a little too lazy and I haven't perfected my agents MD or anything. And so I found in the great, like, I think there is an argument for AI is great in Greenfield because you just start, you vibe it out, you just keep telling it features, it starts programming its thing. But there is this moment where I kind of manually go through the code and just kind of push it a little more in the direction that I like. And I don't want to type out all the instructions, all the prompts it would take to do that. It is, I'm an experienced programmer. I can actually sit down and edit the code much faster than I can describe the changes. I think this is always the problem like tech leads have with junior programmers. It's
Mm.
like, do I take control and just edit the code, or do I tell the junior programmer? In my case, I try to tell the junior programmer, the co-pilot, to do most of my work, but then there's always this moment where I want to lead it down into my style and just force it back into my style. I'm getting to my point, I swear. And this is a part where I actually think that AI's and Brownfield code, terrible term, is kind of great because then it's already locked into your style. It's locked into your architecture.
Yeah.
And yeah, it can do damage. It can go and blow away your architecture. But if you have a substantial code base, it's going to work within your architecture. And I almost feel like it's better because then I trust, okay, the overall design of my app is there. My data flow is mostly baked. The way I have services run, the way I have services talk to each other, that's all kind of baked into the code. And now I'm having it do refinements and features and UI work, and it's doing that all within the context of my code. And so I'm finding I think AI is really shining for me as a control freak in the brownfield scenarios because I don't have to worry about it creating some ridiculous architecture that I don't like and that I have to go back and clean up. So I just wanted to put that out there.
I think what I've also noticed, for example, when I use it in the skiing app, I didn't have to give it a bunch of instructions about how I wanted to
Hmm.
architect my code because it could infer, like you're saying, in many ways. Oh, this is a view model. I'm going to create another view model, and it should probably look like the other view model that's inside
Yeah,
of it, right? Oh,
exactly.
like I can see they're using this. Oh, this is a controller. It should probably look like, oh, I'm making
Yeah.
another RESTful endpoint. It should probably look like the other RESTful endpoint. However, I think the other powerful feature of this is that if you have your code in a place, you can then ask AI to come up with the best practices based on your code
Mm,
base and then generate the instructions for you. Like there is a generate inside of VS Code, you can like, generate custom instructions, but I would almost be more pointed on it. Like I would take a look at what that's doing, take a look at the prompt, and then I would customize it and run it again. And then I would maybe would do one for your UI, for your view models, for your CSS, but give it and say, look at all of my CSS, understand how I structure my CSS, understand how I structure
mhm,
my XAML, how I structure my JSON files, and how I structure and deserialize JSON or whatever it is. And then write the best practice guide for this. And funnily
yeah.
enough, in a Greenfield app, I did this with Apple. I went and I said, go look at all of like the Apple
Okay.
samples and best practices for writing Swift code and
Yeah.
go document Swift best practices and adhere to that. I'm not saying that that's what I wanted, but I don't know anything about Swift.
Mhm.
But I'm like, if you're
Sure.
going to write it in the way, and then go generate those instructions and put them all in there of how you do these things. And that worked really well. So I do totally agree with
Mhm.
the Greenfield Brownfield. And I also would say that because the models have gotten so much more better and they're grabbing more context in their windows and things like that. That's the other part is I don't think we could sit here a year ago and have said that 100% the same. It
Mhm.
didn't feel that way per se as much as it does today.
Yeah, it's definitely trickier now though too because like it's a little bit hard. It's both easy to control its context and hard to control its context. In that you can point it at some files, but if the files are a megabyte each, it's not going to read in the whole file. It's going to use its own regexes and go look around for things. So you got to kind of point in that direction. Speaking of which, so I was working on a fun project. It's actually a project from years and years ago. So in a past life, I used to work on naval ships. Do you remember that part of the Frank story we did on merge conflict like 20 years ago?
Yes, I think it go back to a merge conflict episode. I'll find it while
Oh
you're
no, you
talking.
won't.
Go ahead. Yeah.
Okay, yeah. So many years ago, I used to work on naval ships, and I worked on rudder controls and autopilots. And it's I'm a controls engineer. It's fun code. This is what brings me happiness in the world is writing embedded systems. I don't love working for militaries anymore, so I don't do it anymore. But I do love working on robotics and control systems and that kind of stuff. Well, years and years ago, James, I ran into some code. Not even code. I ran into a chip. The chip fell off the back of a truck. Well, I guess in this case, it fell off the back of a boat. And I was able to read the code off the chip, but this is machine code. This is like
Mm,
actual binary data off of an EEPROM. So this is like really baked into the little chip. So back in the day, before we had hard drives and all this fancy stuff, you would actually hard code all your program code to a little chippy guy. And then the processor would read the code off of the little chippy guy, the ROM, and it would execute that code. Well, this began a long process of I was curious how that code worked. And it was 6809, 6805, 6809, whatever, some ancient old Motorola code. And it's been sitting on my hard drive, James, for 20 years. And for 20 years, I've always wondered what was on that little chippy. And about a month ago, I decided, you know what? We have AIs now, and I am going to investigate what's on that little chippy. And so this is definitely up your alley of like, here is something I am not comfortable with editing and reading raw machine code. I wonder if AIs can help me. So, do you think AIs can help me?
I think that it can do anything. So yes, I think. Well, I
Anything.
well, it depends, right? Because when we think of the AI in a way, we think about the model basically having this um, corpus of data that it has, trained on. And
Mhm.
the question really becomes, is this 6890 or 6809, whatever
Yeah,
it is, 3825 code,
sure.
is it aware of this? And the interesting part about this is I was watching like a Microsoft Copilot, like the Copilot app, like the GPT app, doing the vision stuff. And I think Mustafa, went somewhere and went to someone that had this old machine where they were working on shoes and stuff. It's like, oh, this machine's from the 60s. I can't fix
Mm,
it. And he's like, oh, just like, let me just take a photo of it or blah, blah, blah. It's a little blah, blah, blah. And then it's like told them how to repair it because like somewhere in the training data, it could find the instruction manual,
oh
like
gosh.
whatever language it was written in, it like knew, it has this corpus of data. So the question is
Yeah.
this, does the corpus of data know, and can you refine and can you tell it to actually either suck it in and make a custom model off of it and like to
Mhm.
stream what it is, or does it just have the knowledge to do it? So I actually don't know. My assumption would be probably, but then it could also be not at all.
Yeah, and that's honestly how I felt about it. I know, I not to brag, but I know a lot about machine learning, and I was like, "I'm not sure," because there's really not that much 6809 code out there. It was popular in the '80s. I personally used it. I used the 6812 and 6811 in the late '90s. I programmed that at General Motors, so
Mm,
I was vaguely familiar with the chip. But there's just not that much code out there in the same way that all these models do JavaScript better than Fortran. They do Python better than Beta. I don't know. Name a language. Name a programming
yeah.
language. I still complain about their quality of Swift code. You say it's fine. I still think it's generating subpar Swift code. So I was really curious myself. The one and I've been wanting to try this experiment ever since basically GPT-3 because fundamentally all these new AIs, everyone calls them they're transformers. They're the transformer architecture. And that transformer architecture came out of translation. So from the very beginning, these kind of networks, before we were using them to, predict the stock market and blah, 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 they're just good translators. That's what actually they were designed for, and that's what they happen to be really excellent at. And so I remember thinking, I'm like, oh, I wonder, can this thing translate from machine code into high level code? Now I'm going to talk
Mm,
about C code because I think C code for this is high enough level. I don't need it to become all object oriented or anything like that. And in fact, I remember years ago, back in the GPT-3 phases, we were all joking like, well, compilers are useless now because compiling's just taking one language and converting it to another language, machine code. So why don't we just have AIs be the compiler? Like, just here's some code, generate the machine code, generate the x86, generate the ARM or something like that.
yeah.
I don't think anyone's actually done that experiment because we're all too suspicious of it hallucinating some code or something like that. But if you think about it, there's no technical reason it couldn't do it. And if it can do that, why can't it do the reverse? So I thought I had to give it a try finally. So there's multiple steps you have to take. So step one was to convert from machine code into assembly code. By machine code, I just mean it's bits and bytes. It's just numbers, and humans can't read numbers, and these networks aren't going to be able to read numbers like that. It's too obscure, too esoteric. And so I was happy I was able to dig up some old 6809 disassemblers.
Oh,
So this
okay.
would go from the binary into assembly language. Do you do any
Once you're
assembly anymore, Jane?
once you're in assembly, I think you're okay. No, I do not do any assembly
Yeah.
anymore. No. I've partaken a very, very, very long time ago in the
Hmm.
beginning of there, and it lasted not very long because I'm a higher level programming
Yeah.
language type of dev. But there is a lot of assembly in the world. Like assembly
Yeah.
is out there and has been out there. I don't know how much of it's publicly on GitHub, but I bet there's quite a lot of assembly. To be honest with you,
Yeah. And
it's
in
been
fact,
around.
the problem with assembly, so assembly is a high level language. It's meant
Yeah,
to be read and written by humans, not
yeah.
computers. Computers talk machine code. So even if you have a bunch of assembly, you still need an assembler to compile that assembly down into machine code, bits and bytes that the processor can actually read. And so my thought was, if I can get it into assembly, then these transformers that understand a lot about programming perfect at 6809, but if they see something called like load address register the value 42 into register A, it can figure out, well, okay, something called A is going to have the value 42 now. If it's JSR jump subroutine into something, it's going to figure out a JSR is a classic one. It's been around for a while. So I was
Yeah,
excited.
smart, smart.
Smart. Yeah. There was just one more catch though. So this EEPROM is 64 kilobytes, which generated 1.2 megabytes of assembly language. So
Wow.
you see, that's the human readable part. There's a lot there. And the biggest, it's not just assembly though, because the ROM is also data and code.
Uh,
So it has to kind of figure out what's data and what is code, and these are hard things. So maybe like 10 years ago I thought, "Oh, I got the assembly like 10 years ago. I'm like, I am going to by hand look for every JSR jump subroutine and I'm going to hand decompile all this assembly into high-level C functions." I was able to find my old notes. I got about 10 functions in and then gave up. It was just way too much work. So it was always sad. It was like this project that I always wanted. I've had this EEPROM forever. I've had the disassembly forever. And I just lacked the time and patience to actually convert it over to something high level. And that's when I had the brilliant idea of, well, we've got these giant machines now, these large language models. Let's just pump it through. Do you think it worked, James? What work? Do you think it worked? What model do you think I tried? And did it
it's a good
work?
question.
What would you do? You have 1.2 megabytes of assembly and you want C code out from that. And I should say, there are decompilers out there, but it's hard. Decompilation is a very difficult task. And
Yeah,
that's why I think I think I even tried to use some like heuristic based ones, but they don't
I
work
guess does the model for the model to know about the code, does it need all of that assembly code? Is it going to need all of it in general? So does it mean that
well. Right.
you're going to then have to generate like a custom model off of it? Like take the foundation model and then put this in there, do some training on it so that it knows about it? Or is it like, hey, here's this big file, kind of chunk it and do some things and kind of just crank on it for a while so you understand the code base and then write up something? Because the
Hmm.
thing with when you go into VS Code or wherever your AI code editor of choice is, um, it only knows what it knows. It's if you're like, hey, here is my code. I mean, I guess maybe they have memories now, but like in general, it's just calling the foundational model at the end of the day. It's
Hmm.
not like it, and maybe it is a custom model, but it's not taking your code and taking your things and then training a custom model for
Yeah.
you. That'd be cool, but it's not doing that, right? If anything, it's maybe taking some memories and storing some things, and then it goes into its context window and then shoves it back out, right? But inherently,
Yeah.
it's not rebuilding a new foundational model, Frank dash Frank. You know what I mean?
Yeah.
So I think in this case, if this is unique code, the the right way to do it probably is what I talked about, which is like, hey, I'm going to have to now do some machine learning. I'm going to take a foundational model. I'm going to like take this data, put it in, understand it so it actually understands what it's doing. So I can ask questions about it and do some stuff if it doesn't know about the code. The first thing I might do is just like pop it over into Sonnet. If I wanted to waste to just kind of use a bigger, heftier model, maybe I'd throw Opus at it because why not? The context windows are all kind of the same. I guess you could use a GPT codex and maybe get a huge, you maybe need someone with a huge context window. The
Yeah.
Gemini 3 Pro, I don't know how big, like whatever the tokens are. But you probably have to pay one of those providers, right? You're not just going to get an off the shelf code, VS Code like that has like this huge context window to suck it all up into it. So what I would probably end up doing is this is where inferencing comes in or something like that, where you gotta like do some stuff. I don't know. I'm using AI words. I don't
Mhm.
know anything.
Cool.
But my thinking is like you're using like hey, okay, I'm gonna take a off the shelf model, like a Quen model or something like that, a Quen 3 model or something like that. And then say, okay, we're gonna take this. I can run it locally. I'll spin up, do some training on it, build up the neural network, do a bunch of stuff, and then I'll have this local model that I could run that I could then prompt questions on. Is that the route you went? Because I feel like that would be the route that you would go if that is a route that even logistically makes sense in my very small knowledge of machine learning.
I love your faith in me, and I love that you think I have nearly the hardware it would take to do that. Um,
You don't have a
it
bunch
is
of
great though.
Blackwells sitting around? God, where's your infinite?
I've got 3 H200s back there. They're just sitting doing nothing.
They're chill and they're ready. They're ready to burn some energy. Come on. Put those GPUs to
Um,
work, Frank.
I like your idea. It does have the problem. Let's say, assume I actually did have the hardware needed to do that, because this is a large context. That is the biggest problem here. It's a big chunk of assembly code. The problem is to fine tune a model, you still got to give it training data, and I'm not sure what the training data would be in this case. I could feed it a bunch of Motorola stuff. I could take a bunch of C code, compile it down, disassemble it, show, hey, this is assembly code, this is C code, A, B,
Boom.
learn how to do A to B.
Yeah.
That would be if I was funded, if I was at a lab or if I was at Google and someone wanted to throw me some money, sure, I might go that route, but no, that's not going to happen. What did happen was all of a sudden all these big providers started saying, "We got a million token context window, baby. Come use our million token
Yeah.
context window." What they don't tell you is these LLMs are absolutely atrocious once you get past, say, 50,000 tokens. So it may support a million tokens, like on the spec. And if you give them $2, $3, they might actually consume a million tokens, but they get dumb. They get
Well,
really
oh,
dumb after a
well,
couple 100,000 tokens.
and this is like when you're ripping in VS Code, you see it'll compress the context windows. It actually keeps it
Right.
you can see the context windows. It's like 124 for most of them, or 108 for some of them, or some are 64. But like, um, when you go, you'll see it summarize. And what I've noticed is, yeah, eventually once it's it does it's compressed so much that it has lost some of the things that I want it to know about the
Yeah.
conversation, and it just kind of struggles to figure out the compressed and figure it out. It's like, okay, we just gotta greenfield this chat right now. It's gone
Yeah.
down. We're gonna close down this factory and like start anew. You know what I mean?
Hmm.
Because of it, because you can only have so much context.
Yeah. So the fundamental problem here is the ROM is actually three things. It's 64 kilobytes, no matter what the code is. So that means actually a good chunk of the ROM is blank. It's all
Mm.
zeros. Because if they didn't need to use that part of the ROM, then it's all just zeros. And there's actually no code there, there's no data there, but that still got disassembled and it still
Ah,
consumed a bunch of stuff. So one step I actually took was I manually went through and started to look where are all the zeros beginning and all that kind of stuff. So I manually trimmed down the disassembly just with my
we we
knowledge of.
we call that data cleansing. Clean the
I
data,
cleansed it. Oof, scrubbed it,
cleanse that
scrubbed it
data.
clean.
Scrub those zeros. Get out of here.
Yeah, and the other problem with a ROM, if you think about like generating an executable for your code, is what I was saying. Data is mixed with static data is mixed with code. So imagine you have a function in your code, and then on the next line, you declare a big static array, like, I don't know, a picture or something like that. And then after that, you have some more code. So now we're mixing code, data, code. So the way around that for a human or a decompiler is, well, for these chips, for this processor in particular, there are some fixed memory addresses. When the thing gets rebooted, it goes to this memory address, it reads these bytes to find out what address to jump to and all that stuff. So a sophisticated machine, if it has what's called the vector interrupt table at the end of the code, it can know which parts to go into. And then it can recursively do it. Start there, go find a function, decompile that function, find what functions that calls, go decompile those. That's what I wanted it to do. But you still have to kind of blast the whole context at the thing. And so Google's out here bragging about their Gemini 3. And I'm like, you know what? I'm going to give Gemini 3 a shot at this.
$10. There we go.
Yeah. not even that bad, actually. I forgot what the trimmed code size was, but it was smaller, obviously, than a megabyte. The hardest part for me was deciding what the prompt should be. So I wanted to be very clear to it. I'm like, I want you to decompile this assembly code. Do not hallucinate. Do not assume what this code is doing. I want a line for line conversion of this code to C code. But at the same time, I want it to be readable. I want good variable names, all this stuff, because I could do it line for line C disassembly or decompilation that would not be pretty. And so that's what I did. I wrote out my prompt, I filled that context window all the way up, and shot it off to Gemini. And I don't want to give too much shade against Google here, but I'm going to give a little shade. Oh my God, it just hallucinated the entire thing. It came back to me. It's like, well, I heard you're working on it's like Clippy. I heard you're working on a rudder control system. We think when you turn the helm left, the ship should probably maybe go left. And so we wrote code, and I swear to you, the code was like, if helm left, turn rudder left. And I'm just like, is that really what the assembly is? Is that what I'm getting for my $2 I just gave you guys? I forgot what the cost of Gemini is. But I was so disheartened because, like I said, I've been thinking about this ever since GPT-3. Yeah. And I finally got around to working on it, and it just hallucinated all the C code, even though I specifically told it not to. And I was all sad, James. I was sad. Have you ever worked on something, realized you're not good enough, and then gave it to a machine to do it and realized the machine's not good enough either? Just like, oh, technology. It's like, I'm passionate about this stuff, but it was very frustrating.
I recently, I was working on Baby Smash, and if you listen to the last podcast, and you should get the source code now and like run it after this. It's actually, when you run it, it won't run in kiosk mode, but if you run it in release, it'll run in kiosk mode. It covers everything. And then it also now ties into the accessibility features, and it additionally blocks Spotlight, which is like impossible, by the way. Like, blocking Spotlight like took unbelievably forever. Also, if you try to exit the app,
might have some assembly code in there.
if you try to exit the app, if you try to force quit, right, which would be option command escape, you can't, because the kill activity thing comes up behind it. And I also block command Q, so you can't quit the app. So I had to build in a special way to exit the app, and I even had an emergency backup, which was press the period button 20 times within 5 seconds. So emergency escape app. But in this, the Spotlight, the funny part is, like, I couldn't get it. The machine couldn't get it. I went to Stack Overflow. I found a thread on Stack Overflow of all of these ways of hacking it, gave that to the AI, and it's like, oh, you know what? I think one of these might be correct. And it analyzed everything, and it put one in, and sure enough, it worked. It actually had to write like C code, C++ code, and invoke it from Swift to do some crazy, I have no idea what it's doing, but it worked. But it was the thing, is like, I couldn't get it to work. It couldn't get it to work, but somebody else on the internet got it to work, Frank. So
it's probably Quartz. I love that, like, Mac is old enough that it still has like some next step code in it, still has some Quartz code in it. They want you using Swift UI, but man, it's got the old stuff if you need it. It's back there somewhere.
I was just watching a YouTube. This is a side tangent. Is there's this video on like tips and tricks for Stream Decks because I got this new Stream Deck and it has all the dials. I'm like, how do people use it? I'm just kind of curious, tips and tricks. And the one guy was like, oh, you know what I have is I have a dedicated theme toggle. He's like, sometimes I'm recording a podcast, everything's in light theme because my Mac changes by time of day. He's like, so I have the thing. He's like, you know what I wrote? He's like, I asked ChatGPT for an AppleScript to do
Okay,
it.
yeah, of course,
So
yeah.
it executes an AppleScript. And like, funnily enough, apparently like these models are pretty good at AppleScript, which like I would
Oh,
never
great.
use Automator and use AppleScripts ever because I have no idea to do it. But apparently
Oh,
just ask the model to do it and it'll write it. I was like, dude, that's a pretty smart idea. He's like, I wrote an AppleScript to toggle like do not disturb or whatever.
mhm.
Because it's
I
in there.
I I've tried to write AppleScript before, and that is a weird programming language, and I've given up every time. So maybe thanks for the tip. Pro tip from James:
AppleScript.
make the AIs write the AppleScript.
I'll figure it out. Yeah. So I was like, wow, that's pretty cool. Yeah. Anyways, I digress. So where were we at in this story?
I'm all depressed because I tried to do it the advanced, and then I decided, what would James do? This is what I always ask myself all day
Oh, no.
long, and I'm like, James would just ask Copilot to do it. So I opened up the code in VS Code, opened up the little chat window, set it to Sonnet. I didn't even use Opus because I was feeling kind of cheap that day.
Yeah.
I was
A
already
1x.
depressed.
Yeah.
I'm one exit, baby. That's one's already enough. One's way bigger than zero, you know. So I just set it to Sonnet, gave it basically the same prompt. I'm just like, what's it hurt? You know,
Yeah.
copy, paste, hit enter. Just let's see what happens. And what happened had to be the longest chat history. You know how, like, when it goes a long time, VS Code's like, do you want to continue doing this? This thing's been running for like 6 days now. You're like, yep. Yep. Keep going, baby. And it's like summarizing context. Did that like 5, 6 times. But
Oh,
it's
yeah.
actually doing what it should be doing. Like how I was describing of actually trace into the function. Okay, this function calls these other functions, subroutines, whatever you want to call them in this assembly code. Go find those, go find those, go find those. And my God, James, it started pumping out code. And it started pumping out code with like comments like, this
Wow.
function is replicated at this assembly memory address. It does this and that and this other thing. And then it would have like pump out another one. It's like, ooh, I see you are emulating 32-bit math. I'm like, yes, I am emulating 32-bit math. I'm like, I hope I'm emulating. I guess that's what the code is doing. And it was a fascinating walk down history. It was really exciting to see this thing slowly pry apart. This is what I was imagining 20 years ago, what I would do myself as like a hobby project. But instead, I got to watch the robot do it. And this was much better because you just sit back and it's like watching a movie unfold. It was like, okay, I think you're reading a button here. I'm like, oh yeah, it's I think you're displaying something on an LCD screen. I'm like, well, I am displaying something on an LCD screen. And it just started tearing through that code and it was great that it kept having pointers back at the assembly too. So I think this is where I kept telling it, like, please don't hallucinate. Like, everything has to actually be, you read this in assembly, this is a faithful representation of that. And yeah, this was Sonnet, and it just, I want to give all credit because it just crushed it. Like, out came a PID controller, a proportional
Wow.
integral derivative controller, a closed loop control for how this thing should work. I always thought this code was a rudder control system. Turns out it's a rudder control system plus autopilot. Little
Oh.
extra feature there. It had subroutines for measuring its own consistency with the ROM. So
Wow.
like you know, today we would like we have like hash functions and we would compare the hash of the code to make sure that the ROM wasn't corrupted. It had that. It implemented it. It,
Wow.
it did the like RAM startup. You know, remember the old PCs? They'd be like testing memory whenever you're booting
Yeah.
them. That code was in there. And so it would write like different memory patterns to the memory, read them back, and make sure those memory patterns were there. That code was there. The hardware abstraction was there. Things that I always wonder. I write PID controllers all the time. They're like baby's first control algorithm. Everyone uses them. We all use them for things they absolutely should not be used for. But it's such a simple, elegant algorithm that we all just use it. But there's details to it, James. The integral. The integral can get very large, and then all of a sudden you're feeding very large control signals to something. It's called integral windup, and every single controls engineer in the world has their own way of solving the integral windup problem.
Wow.
And it broke out exactly how this code does its integral windup. One of the simplest possible ways to do it. You just clamp the values at certain means and maximums. But it was so cool to see like real embedded code come out of this thing, not hallucinated stuff. Like this is good, well engineered code because it's literally running on warships out at sea, like that are functioning today.
No.
This chip fell out of the back of a working vessel, so like this is real code. And so it was so cool to see very well engineered code coming out of what was a 64 kilobyte file sitting in my Dropbox for the last 20 years. And finally, all its little secrets had been revealed to me. It wasn't perfect the first time, but we're getting long in this podcast. I just want to say, like, it succeeded and it was
Wow.
awesome. And I loved it so much. It was so exciting for me.
That's crazy. That's so cool. It's a cool journey. Also, you can listen to Frank's crazy journey, merge conflict.fm/132.
Ooh.
That would be it. Yeah, that's wild. I mean, I think it's such a cool journey. And also, to your point, we have all of these different AI services out there to generate stuff. Give it a go. And you'd be really surprised. A good example of this is not as complex as what you're talking about. However, I will say this. I was working on Baby Smash and I need a new app icon. And,
Hmm.
this is a transparent background for the app, the icon composer thing. I wanted, different shapes and things and smiley faces. And I asked GPT-5, I asked Sonnet to do this inside of VS Code, which it does generate images fairly decent. But it's mostly SVG art and it doesn't do a
Yeah.
super great job at it. So I was like, you know what I'm going to do is because it's not an image generator, right? It's not
Hmm.
inherently that's not what it's made for, right? But it can generate SVGs and then convert those to PNGs. So I just booted up like Microsoft Copilot. Like you would open up,
Right.
ChatGPT, and I was legitimately like, "Hey bro, like can you just go and create an image for me that
Yeah.
well what I did first, by the way, which I think is really funny. I'm going to send it to you on iMessage. So I said, this is amazing. This is a good prompt for everybody. I went to my app and I said, I want you to generate a prompt for me for an AI system that generates images, but I want you to take into consideration all the requirements and what this app is and what a great app icon would look like. So it came up with this beautiful prompt, design requirements, 1024 by 1024. It's a Mac OS application, transparent background, playful, fun, child-friendly aesthetics, bright, vibrant colors, gradients, include large, bold A letters in the center with pink, coral, greens, colored geometry, numbers 1, 2, 3, floating numbers like BC, cartoon illustrations, joyful. Like I asked it for a prompt and it said, do not include all this stuff, right? And I'm going to send it to you on my iMessage. It's going to have the transparent background, but you imagine like what I did here
Hmm.
for it. And it generated this stunning, just beautiful,
Ooh.
um, and this made sense because it's like very kid friendly application. And it generated this like beautiful, like art that I dropped in.
Oh, this was an SVG. I hope you'll put this in the show notes so everyone can see. This is
So
fantastic
I
because
went in. So this was not inside of GitHub, not inside of GitHub Copilot, but inside of
Mhm.
Microsoft Copilot, the Copilot app, and it generated a PNG, not an SVG, a
Oh,
PNG,
okay,
because
got it.
it's an
Okay, okay.
image generator, right? And it
Right.
knows how to generate
Okay.
images, just like GPT-5 does, or whatever. You know what I mean? Like
Mhm.
ChatGPT does. So it's just like,
Mhm.
but inherently, the code editors aren't like pump. They're going to pump out SVGs. They're going to pump out PNGs. But this thing can create beautiful artistic artwork because it can generate beautiful images. So
Yeah.
I was like, wow, this is so cool.
Graphic design. It's funny how many of them won't do a transparent background though. Or you ask for a
Mm.
transparent background and it actually renders like gray and white squares. You're like, "Oh, buddy, so close. Almost. You almost got there." No, this is a great icon. Good job. I love that now that Apple has Icon Composer, we're all having to actually do very boring gradient backgrounds and then just separate out. foreground image and all that kind of stuff.
Yeah.
Uh, oh yeah, yep, okay. So you went okay, yep. Um,
So
cute,
that's what it looks. I
very
sent you
cute.
the app icon, and
Yeah,
anyone can go to
rendered.
my GitHub and you can go to the Baby Smash repo and you can see the art. I have an art folder, but yeah, it's like really good. I was like, wow, this is really good.
Yeah.
I'm not saying it's as good as a professional icon designer, but I was like, you know what? In literally 3 minutes, so that was AI using AI when
Mhm.
one AI thing wasn't good at one thing, like your Gemini thing wasn't good at it. Try another AI
Yeah.
assistant to do it and see how it bumps out.
I do hope they all get better at SVGs though,
Yeah,
because like doing
me
it
too.
at the pixel level is just a little much.
Yeah,
But yeah, excellent, excellent, excellent. Well, now you can generate me an autopilot icon.
there
So
you
the
go.
worst part is like this was all just for my own fun educational experience because as a controls engineer, I want to know what other controls engineers are doing. Like, am I doing
Mm,
a good job? Am I under engineering? Am I
yeah.
over engineering? Am I at the right engineering level? And it was great to see like a production run hunk of code. I learned to program by reading other people's code. And so this is the weirdest extension of that ever, that I was able to take like a binary image, convert it to assembly, convert that to C, and then learn from that code to like compare and contrast my own algorithms with all that. I should say that like I already had my own rudder control and autopilot that I wrote 20 years ago. So I'm not actually going back and changing anything. But it was fun to see like where they line up and where they don't line up. And I just thought it was just one of those fun, not possible 5 years ago. And now it's just something I did in an afternoon for funsies.
That's crazy. Yeah, that's cool. Well,
Good world.
if you can, you know, if you can, so somebody once told me now. This I'll leave on this is there's some always controversy on the internet, but someone made like a bold statement. It's like, oh, I would have never done this without AI, and that is partially true and partially false. Is that we wouldn't have the time, effort, or energy
Mhm,
to be able to prioritize some of these things. And I was talking to Scott Hanselman about this. And what he was telling me is like, we're now able to kind of upshift some of those lower priority things to a higher priority because you can parallelize them and spend a lot less time on them to maybe get something out of it or get something out of it completely because you've had this, you've tried, you've done some
mhm,
stuff, you probably, given the a vast amount of infinite time, you could have figured it out, right?
yeah,
However, it's not going to be your priorities because this isn't your business, right? Frank has to
mhm,
make iCircuit and get that sweet
mhm.
circuitry money out there, right? So I think that's the thing that it's that I wouldn't have time to put effort and energy into so many projects. I'd be more focused in on it. So would I have holiday hacked and built a thing? Yes. Would I have holiday hacked and built 10 things? Probably not. I think
Yeah,
that's the thing. Would you have ever done this without it? Maybe, right? But I think in this regard, like this is a really cool example of taking something that is not unfathomable, but doing it
mhm,
in however little time you did, and then have a really cool story about that journey that you went on. So that's cool. Thanks for
yeah.
sharing, Frank. I really appreciate it.
Yeah, and I just wanna add, like, if it was about the journey, then it would've been worth, spending 3 months, go off to an
Yeah.
abandoned island and work on it, but that's not what I wanted. What I wanted was the knowledge of the code, and this got me to that actual place I wanted to be. I there was nothing to be gained by the hard work of decompiling this myself. Everything was to be gained by the knowledge I could get from the actual thing that I could actually read. So that's why I don't feel like I shortchanged myself at all in the process.
Yeah. And I think also you said it earlier, but when you're going through this process, you get that deep insight into what and how it's thinking really fast, right? You see those messages, the thinking bubbles come up, it's thinking, it's doing stuff. I love to try to parse those. I go back, I expand them. I'm like, what were you thinking? Oh,
Mhm.
okay.
Mhm.
I'm interested, right? I'm interested in its thinking process. Is it going down how I would have went down it? Maybe I could course correct it in a different way, and the next prompt to go down a different way. But anyways,
Yeah.
Frank, I love it. We are at episode, good gracious, 497. We better do something spectacular for 500. That is coming up before I think the end of the month. So let us know what you want us to do. Go to our YouTube, go to our Twitters. I'm sure we'll do a live stream. Maybe I'll put a form maybe in here, like a
Mhm.
question bag that you can just submit to. I'll put that in the show notes. So if you're in the show notes, I'll have a form that you can fill out and anonymously
Cool.
write any question about anything. So that way you don't have to leave a public comment. Some people don't want to do that. So there'll be a Microsoft form because I'm a company man. You can do that. It's just like any other form that you use on the internet, but it's included with my Microsoft 360 subscription. All right, that's gonna do it for this
And
week's
throw
merge conflict. No, we got something else. Oh gosh, go
Oh,
ahead.
no, I was just gonna say throw in some of your favorite moments and things too, because I love reminiscing. If you can remember, it's been 500 episodes, but if you can
Ah,
remember anything that's happened in the past, throw those into the form too.
the form will be just one blank box. Merge
Okay,
conflict.
great
It's gonna be
form.
called. It's gonna be new. I'm doing right now. New form. No
Okay.
no copilot for needed for this.
No,
Merge conflict 500.
free
Start
form.
with
Prompt us. Prompt James. Prompt
ooh
Frank.
text. I'm even gonna give you a long answer. It is gonna be required. A long box. Anything you want. Boom. Ship it. Saving. So whatever it is, you tell us. All right, that's gonna do it for this week's Merge Conflict. So until next time, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.